With that, I would like to invite our next speaker. I'm sure everybody here in the audience know him. Those which come outside, please take a seat. There is quite a lot of empty chairs. Take the seats. And I would like to invite Benny Farber, which is the leader of the largest AI community here in Israel, and also creator of the podcast AI Simple. So, Benny, the stage is for you.
Hello, guys. Wow, such a big honor to be here today. First of all, good morning, everybody. It's such a big honor and it's such a big respect for me to be here. So thank you for the opportunity. Is there somebody that knows me from the crowd? Wow, perfect. So what I do today, I lead the largest AI community in Israel with 130,000 members. You can look for it on Facebook, ChatGPT Israel, ChatGPT in English, Israel in Hebrew. And I also host the most known podcast, Hebrew podcast in Israel that's called AI Pashut. It's called AI Pashut because it's meant to be for simple people, you know, as me, as you, as everybody here. And all the content that I do, if it's episode on the podcast or it's like, I have also a newsletter and everything that I do is very simple and everyone can understand. This is what I do. And before I came to the stage, so Rotem, one of the organizers, she's like, how old are you, Achi? And my age is always an issue. So I know I look a bit older, but I'm only 26, all right? And I know I look a bit older, but I'm only 6. And as I said, what I do, I lead the biggest community. You can look for it on Facebook, and you can listen to the podcast. You can do it only after the session, of course. Today we have a really interesting session. We're going to talk about AI applications, and the thing. Sorry, and the thing that all the applications we're going to talk in this session, they're all Israelis. So it's such a big honor and big proudness of an Israeli proudness to see all those young entrepreneurs with the applications they're going to talk about AI. And Israel is such a big leading country in the AI industry. So it's really proud for everybody in here. And so without further ado, I want to call to the first speaker, Ofir Bibi from Lightricks.
What we'll talk about today is like a really brief history of text-to-video models. And the reason that it's brief is a year ago or 2 years ago is already ancient. And also it's from the Lightricks perspective. There's a lot going on all the time. So I'll talk about what we do at Lightricks, which is quite a lot. So the thing is that a lot of people come to me from inside the company, outside the company, and they ask me, what's going on in video generation? Tell me about what's working, what's coming up, what's not working. Is it all just hype? And my answer is usually yes to all of it. And then I start, I have this go-to. It's super loud, but I'll talk over it. And I showed them this ad. It's a really nice ad. Like, who thinks it's a nice ad? Just person. So I won't let it play out for time, but at the end there's like a bottle of perfume and all you have to say is like J'adore, and it's a good ad. And that was completely 100% generated in LTX Studio, like in one of our apps. And there's a lot of stuff that if you look at the ad, for instance, why it's really good for ads, because you cut from one scene to another and maybe scenes are still very short. But if I want to do a slow burn movie where every shot is much longer, then it's pushing the boundaries of what we can do today. Why am I talking to you about this? So like I said, I'm Phil. I'm from Lightricks and I manage all of the research at Lightricks. And if you don't know Lightricks, what we do is we really try to bridge the gap between imagination and creation. We try to give people who want to create content, who want to be creative, all the tools and platforms they need in order to do that. And we have different products. We have stuff that also connects brands and creators and things like that. But one of the most relevant products today for what we talk about is LTX Studio, which is a story creating platform. It has video generation at the heart of it. So we have things that anyone who wants to create might want a very specific scene. People are a lot of times pixel obsessed, and they want to see different options. They want more controls, which is something we'll talk about. And they want, like I said, longer scenes and better looking scenes and so on. So since a lot of people have been sitting here, like in Raja's lecture and also before, I won't go over what are the fusion models, but just to make sure that everyone's aligned on this specific image. Then what we do is we basically put in noise into a system that was trained to denoise and to estimate what is the noise and get a final image. And what we can do is actually get step by step into an image, right, and less noise. And the interesting thing about it is that we can control it with text. Okay, if we just put in noise and get some random image, it's nice, it's impressive for a couple of years ago. But if you can control it with text, that's interesting. So text that goes through embedding, goes through and injected into the model through cross attention. Okay, and that's important for the people who want to know a little bit about the details. So if a block in the denoising model, the unit has res block and cross attention, the text goes in there. But text is not enough controls. Like, I don't know who here tried it, but text to video, just as is, it's really cool. It's not a lot. Like, I can write some text, I can write a lot of instructions. If the model actually can adhere to the prompt, if it's really long, maybe I'll get something cool. Maybe I'll get something close to what I want. I won't be able to actually control it. And the first thing we found is that people need control. Even in very, very, pop culture apps that we do, people want control. They want to be able to say, this is the structure I want, this is where I want to put myself or people or objects. And the first control, like if I just say a girl playing a guitar, then I get something. It's a girl playing a guitar. But if I want her to be in a very specific pose, I'm not able to do that. So one of the first really successful methods is something called ControlNet. Came from Stanford and March last year. And you're able to give all types of controls. You can give pose controls, you can give edges, and you can just add another layer of control into your model. The way you do it is you take the control you want, the input control, in this case a pose, you put it through a model that you train for it, that's a control net, and that control net plugs into the model itself through, well, again, basically through zero convolutions. It's injected, the control is injected into it. For those of you who are interested in what zero convolutions are, they're just a way to kind of inject influences and adaptations into all these diffusion models very slowly during training. It's a one-by-one, like a point-wise convolution that starts from zero and kind of slowly raises up. Okay. All of that was just the premise because we didn't talk about video. We talked about diffusion models and generative models, creating images and controlling them, which is, like I said, super important. Why it's interesting? Because just like the control module here is a module that kind of adapts and injects into an existing model, a couple of months later came a work that was called Animate Diff, which was one of the works that really caught on in the community as well. And that work basically says, okay, if I can train a module that does control, maybe I can train a module that tells the model to look at more than one image and have a temporal connection between them, right? Which basically, what they did is they added the motion module into the existing model. Again, added 0 convolutions on top of it in order to be able to train, and trained it with multiple frames from video, where the motion module, again, for those interested, is basically a temporal transformer. It's a self-attention layer with positional encoding so that it tells me which frame I'm seeing, and it connects, the self-attention connects between different frames in time. Okay, important for, next up, the spatial resolution or field of view of it is limited. Okay, that's one of the limitations of that work. Basically, what it allowed is to take any base model from the family of models where motion modules were trained, mostly stable diffusion, and plug the motion module in and get basically videos. So what was interesting is that it was really inefficient and hard to train in order to get to good results. And the animate diff module that came out of the original group was just 16 frames. What they mostly did is train it on 4 frames per second, which means they could generate a video 4 seconds with a lot of gaps between the frames. So you can fill them up with film and other interpolation methods, but still, it's pretty it's pretty short. There's a lot of gaps. You can't do a lot of motion. And what we did at Lightricks, which was really one of our first endeavors into video and video generation, is create long animate diff. Long animate diff is a model that builds on it and can generate 32 frames and even 64 frames. It also, there are versions where the positional encoding can actually give a timestamp where I can decide if I want frames that are closer to each other for a shorter video, but more motion maybe, or farther away from each other. That model we released open source. You can find it on GitHub and Hugging Face. And it was really one of the places where seeing the community latches onto a new model and get amazing results out of it, better than the ones we were able to even to make with our own researchers. But when you give it to creatives and people who just want to squeeze the juice out of it, they do. So that was our first endeavor into it. I will say, just before I go into the bigger picture, is that when you look at this, this is like the first. There were all kinds of video models, like I said, almost ancient history. This is kind of the second generation of models. Basically, the improvement on this was that in models like stable video diffusion and other models that came out in the same second generation era, is that instead of just training the motion module, they added more temporal layers and kind of unfroze the entire model and trained all of it together. Okay, that was basically the biggest change. But when you change the entire model, you can't actually plug in all kinds of modules that you built on top of a base model, right? So if the base model is images and you plugged in animate diff, you can also plug in control nets. You can also plug in a lot of other stuff. And then if you want someone to be able to move, you can insert a control that is frame by frame and get some motion that is much more controlled. Okay, these are results. So for instance, in LTX Studio, people are looking to animate specific characters. They're looking to change the camera view. So there's a lot of types of controls that you need to inject into the models you use. However, like I said, there are a lot of limitations there. So one of them is the consistency of frame by frame. So if you look at a person, consistency is immediately apparent, right? If the face changes, if the clothes change, you see it's not consistent enough. The main reason for that, basically, and you can see here in this example how the girl changes, is that, again, there's this very limited spatial field of view for the model, right? The model does not see, there's no self-attention that sees everything around the frame. So if there is a lot of motion, what happens is there's no self-attention between these areas, and then there's nothing holding me on the consistency side. If I do less motion, I can get more consistent results. So one of the interesting findings that we found is while working on long animate diff is that the original animate diff at some point released like an adapter. What the adapter basically did was create a mode collapse on the base model, and they just created very similar images. So the motion is much more smooth, but it's all kind of toned down. So the first example here is animate diff with the adapter. The second example is animate diff without the adapter. It's much more lively. There's more motion, but there isn't any consistency. And we also trained our model to be both consistent and lively. Okay, so that was one change. Moving on, there's the new generation of things going on. So I guess, everybody here heard about Sora, right? So that was like the genius of previewing a model before it's even ready and getting a lot of excitement. Since then, there are a lot of releases. We're also working on our own next generation video model in Lightricks. Some of the main changes. So there's a lot of stuff going into it. There's a lot of data needs and captioning for video, which is complex. The encoders for latent spaces need to be video. And what going full on video and not just base images and then motion on top of it allows you is from these types of examples where you get frames by frames with some gaps, you can actually go and get videos that you create. So for instance, nowadays, we're already creating videos of 128 frames and making the most out of it. There's, of course, a lot of other stuff going on, autoregressive models and not diffusion, and more stuff coming up. If you're interested, you're also welcome to contact us and join us in this effort.
Yes, there are some questions. First of all, thank you very much. Very impressive showcase. Would you please say a couple of words about LTX target audience? Are you mostly focused on professional content creators, or that's the mass market product? That's the first point, and because I was able to check your beta, and I was really impressed. But I saw, as you mentioned, that a lot of controlling tools are implementing, and seems like it's not like Instagram for mere models, or more professional tool. And if I'm thinking about the mass market adoption.
Right, so like LTX Studio is a whole other lecture, but in general, the thing to understand about LTX Studio is what we see is that diffusion models or generative models as the rendering engine of the future is kind of taking over. We're able to do much more to talk to these models in a much better way. So I think we'll see different flavors of LTX Studio in the future. Currently, LTX Studio is geared towards people who want more control, which are more professionals. But there's a lot of people, mass market, that still want a lot of what it's offering. So it's a mix, but it is something that's a bit geared towards production houses and professionals and stuff like that. Currently, we're opening it from the beta like this. In the coming 3 days, I think, and it will be available for anyone. But yeah, it's a bit more than our mobile apps, it's also a web app, so it's geared towards a bit of a different audience. Yeah, for sure. It is very different. ControlNet on an image-based model, you give it a frame-by-frame control, and it kind of works because, well, it scales because you can think about the how you generate the controls as well, and it's frame by frame. It's very accurate. When you generate the entire video, you usually need to find ways to control by sparser inputs, right? Sparser controls. Like for instance, if you want motion in some direction, then just give that direction and not my pose going like all the way here. The main thing is that it's harder in video models that you train the whole model to be able to kind of mix and match control abilities from other models that someone else may be trained. You need to build the module itself, the ability to control itself into the model or as an adapter, but that is a fit to a specific model. Yeah.
I have a question.
Yep.
Here. Yeah. So this is right the approach of taking a complete video and removing some frames and tell the model to recreate the frames, and then you can recreate the model or adapt it in the middle by inserting different frames of different controls you want?
Yeah, so like I said, if you only build a model that takes text as a control and outputs a video, you're pretty limited. You have to give it, so one type of control is give me a first frame and a last frame and interpolate everything in the middle. So once you allow for image conditioning, which is frame conditioning in this sense, first frame, last frame, it's something that needs to be built into the model in terms of inputs. But yeah, it's part of what we do and what we have. There are also examples of works like sparse control is a work on top of again image-based models that does exactly that, and reference net and all kinds of there are all kinds of controls.
My question is about on-device application. Do you work on models that will work on device?
Yeah, so I wish. No, in image generation, yes, we actually put some parts of what we need to do also on device. A lot of companies and hardware companies are geared towards doing it. Easier in Apple, harder in the fragmented Android device market. Qualcomm are great, but in video generation, like I didn't say it during the lecture, but training these models and inferencing these models is a lot of engineering magic. Okay, it's a lot of squeezing the current hardware to the edge. So while there is a lot of also science and research and new attention layers and stuff like that, it's a lot of engineering. So I think in terms of getting that kind of stuff into mobile devices is a couple of years away.
In extension to that, can you say something about the size and architecture of those models, the video models that you're using?
Yeah, so actually like the examples I showed are from a 1.2 billion parameter model, small one. Billion as in with a B. Now the smallest model we trained as to start scaling up as a 600 million parameter model, went to 1.2, went to 2, and so on. We also want to open source our model at the end because we are focused on our products. So we are trying to create also smaller models for people to be able to run on their hardware, but it needs to scale up. Yeah, it's actually a transformer diffusion model, so it's a bit different, but yeah.
All right, that's it, guys. This was the last question. Thank you to Ofir. If you have, any more questions, so Ofir is gonna be here, you can ask him whatever. I have a couple words to say about Lightricks. Such an amazing company. I personally use their applications such as VideoLeap and PhotoLeap and whatever, and I really recommend. I forgot to say, my podcast, AI Pashut, like a month ago, he had the honor to get into a second place in the Pritzat Hashana, like the new podcast of 2023 in the Geek Time. I can say tournament or something, and this is why companies, such a big companies like Lightricks, actually coming to get interview in my podcast. So if you want to hear more about Lightricks, episode 59 in my podcast, the AI Pashut, we talked about the LTX studio and the future plans of Lightricks and all those.